All right, here's our first example of a rational function. I'm going to remember to look back at the tips and the critical points and the how-to steps, and that'll guide you as you practice more and more of these. But I'm going to start off here with the x-intercept points, or the critical points. So x-intercept point. All right, that happens when y equals 0. So technically I have to have 0 equals x plus 2, nope, x plus 3 on the top. Now it turns out this has one of the shortcuts I was telling you about. The shortcuts involve focus on the dominant division, the top, or the bottom, and look back and study those shortcuts. And I'll do this the long way so you can kind of be convinced, but the x-intercept is only about the top factor, not the bottom. And here's why. Watch what happens when we solve. I want to get x by itself, so I have to clear the fraction. I'm going to multiply by x plus 2. That cancels. And what's left is, what's left is 0, because x plus 2 times 0 is still 0. The equation for the x-intercept really boils down to only the top factor. I didn't need the bottom. It just canceled out anyway. So we can shortcut all of this work. And the shortcut is, hey, it's only about the top. And when we solve this, minus 3, of course we get negative 3 equals x. So our x-intercept point is negative 3, 0. I'm going to put that on my graph right now, get that taken out. That's the first thing I've got now. It's counting by 2, so negative 2, negative 4 is my point, negative 3, 0. Next, so remember the shortcut there was about the top. I'm going to put a circle around that, or a box. Another important point is the y-intercept point. That one is easiest. X equals 0. So technically I'm plugging in r of 0. Hey, stop doing that. Don't want you to give it away. So when we plug in 0 plus 3 over 0 plus 2, we get 3 halves. So now we've got a y-intercept point at 0, 3 halves. So the rational function is going to have to cross at 1.5 or 3 halves. Now when you're graphing from scratch, you will not see these dotted lines here. You'll need to put those in where they belong yourself. Unfortunately, they showed up. I forgot to delete them here, but right there is our y-intercept point at 0, 3 halves. So the rational function is going to have to cross those two values, those 2 points. Okay, so next, let's do the vertical asymptote. Vertical asymptotes are pretty straightforward, but there's a shortcut to direct our focus. The vertical asymptote, what does that relate to? Well, that relates to the bottom. And so if we concentrate on the bottom, x plus 2 cannot be 0, because that's where we're dividing by 0, which is undefined. So what we learn from that is x cannot be negative 2 in the domain, which means the vertical asymptote equation is this purple line, x equals negative 2. Oops. Next, not next. This vertical asymptote is going to have tails that can go 4 different ways. They can have one up, one down, both up, both down, and we don't know which one right away. However, that 2 is in the bottom. Anything about the vertical asymptotes is in the bottom. And it has to do with x plus 2 in the bottom is degree 1, which is odd. And that tells us a big clue. the tails go in opposite directions. So they're not going to be both up. It's going to be if this one's down, then that one's up. Or if this one is down, then that one is up. Oh wait, is that the one I just did? Maybe so. But I think you get what I'm saying. The tails are going in opposite directions. Now we don't know which way it is. Up first, then down, or is it down first, then up? We don't know yet. Now we'll have clues that'll help us sort that out later. Next, I want to look at the horizontal asymptote. Okay, now how do we find the horizontal asymptote? Is there a shortcut to help us analyze this whole process? Well, it'll take some getting used to, but there's three of these things: the dominant division, the top focus, and the bottom focus. Well, the top focus gave us the x-intercept points. The bottom focus gives us all this vertical asymptote information. The dominant division is going to tell us our horizontal asymptote. So y is going to come from x over x. Those are our leading terms. So the horizontal asymptote is going to have an equation, y equals 1, because x over x comes down to 1. Okay, so I'm going to write, there's the horizontal asymptote, and I already wrote down the vertical asymptote. A couple more advanced things. Well, crossing, there's different ways to do the graph from this point. You can kind of guess and check by plugging in numbers to find out which way the tails go, up or down on the vertical asymptote. Some people do that. But sometimes it crosses, and that makes it a lot more complicated. And so I propose that you look to see, does the rational function cross? I should keep it in red. Does it cross the horizontal asymptote? Y equals 1, question mark. So we're going to have to solve. 1 equal to x plus 3 over x plus 2. We got to solve that. And we want to find out if there's any x's that make that equal, because if there are, then there's a point where it's going to cross. Maybe right there. We don't know until we solve it. So let's get x by itself. Well, in a similar way, I'm going to clear out the fraction, x plus 2 on this side, x plus 2 on that side. Well, 1 times x plus 2 is pretty straightforward. I'm going to have x plus 2 equals x plus 3. Oh, wait, this looks weird. Let's get x by itself, minus the x to cancel these. But wait, minus x on both sides does cancel, and all the x's are canceled. What the heck does that mean? Well, that's impossible. 2 cannot equal 3, and that is an important clue for us. The equation is impossible, which means y never equals 1. So it does not cross the horizontal asymptote. Now that's going to be helpful for graphing. Oops, 2 equals 3. I got to go fast now. I only got 1 minute left. So you guys can erase that. And I can't pause this. I got to learn how to do that. But it doesn't cross. We're going to use that fact. And we're going to start putting some details together. Okay, so to graph this guy. All right, I can have a tail on the top branch here or the bottom branch here, or I could have one that theoretically crosses. But wait, we just discovered that it doesn't cross. So no branch is going to cross the horizontal asymptote. Now sometimes that does happen, but not in this graph. Now also, rational functions never, They never cross vertical asymptotes. You can cross a horizontal, but not in this one. So we're not crossing, and we have to hit this point. Well, the only way I'm going to hit that point and not cross is for my branch to be entirely on the bottom. Now, we also learned that the tails are opposites. I can't have two tails going down. The tails have to go in opposite directions. So automatically this tail is up, and automatically I have to go through that intercept point, and automatically I know it does not cross here. That will not happen because of this over here. It doesn't cross. So it's going to have to be entirely above the horizontal and cross. And there we go. We got a quick sketch. Now I've accidentally displayed it a few times, so you kind of know that's what it's supposed to look like. And there's the actual graph. You can see that my sketch is a little rough, but it's pretty accurate. So I want you to get used to this kind of analysis so that you can really understand these rational functions. Come back and practice this on your own later, but I have a couple more examples for you.